In this video, we'll be looking at conversion tables and a variety of compound measures. We will construct a conversion table from a ratio and then use it to convert from one measure to another. We'll then look at a range of compound measures which can be displayed on this type of graph and see how they can be calculated. Before watching this video, I'd recommend watching the video on measurement and conversions. That way you'll have a good grasp of measurement and time, as they're used quite extensively through the following processes. In this first graph, we're told that 5 miles is roughly equivalent to 8 kilometers. And we're asked to first use this information to draw a conversion graph, and then to convert a speed from kilometers per hour to miles per hour. As we know that 5 miles equals 8 kilometers, we can find these points on the two axes and mark where they meet. We can then draw a line from the origin, or 0, 0, to that point and beyond, like this. If we're asked to use this line to convert a speed, as in this case 70 kilometers per hour, and the chart doesn't go up to 70, we can choose the largest amount on the graph that is a factor of 70, to save doing any complex division to calculate what a multiplier would be. In this case, we can use 10 kilometers, which would convert to roughly 6.2 miles using the conversion chart. As there are 7 tens in 70, we can multiply 6.2 times 7 to get 43.4 miles. This means that 70 kilometers per hour is roughly equal to 43.4 miles per hour. Obviously, you can do a more exact calculation by dividing 70 by 8 and then multiplying by 5, which give you 43.75. However, this gives a simple conversion that can be used by someone who may not understand the process. These types of graphs are used in many areas of real life, where a simple visual representation of conversion is required. Many times they're used in currency conversions, which we're going to see in the next question. In this question, Tim has 300 Bahraini dinar, or dinar for short, and £800. He buys a flight that costs 900 dinar, and he uses 300 dinar and some pounds to pay for it. We're asked to work out the pounds he has left. Let's start by subtracting the 300 dinar from the 900 of the ticket price. This leaves us with 600 dinar left to pay, with the pounds that he's got. We want to convert the pounds to dinar, and choose the largest amount on the scale, which will easily go into 600 dinar. We can see that 300 dinar is included in the graph, and that it equals £100. As 2 times 300 we equal 600, we know that the rest of the price will be 100 times 2 and give £200. As he started with £800, we can subtract 200 from it and state that he will have £600 left. In the next question, we're asked to convert Wendy's weight from 75 kilos into stones and pounds. We have a conversion graph for kilos to pounds, and it also states that 1 stone equals 14 pounds. If we look at the largest number on the conversion graph that goes into 75, we can see that 10 kilos equals 22 pounds. As 10 is quite an easy number to multiply, I'm going to use that. 10 times 7.5 is going to give me 75 kilos, so 22 times 7.5 would give us 165 pounds. We'll then divide this by 14 to get 11 with a remainder of 11 pounds. So we can say that 75 kilos equals 11 stone and 11 pounds. In the next question, we're going to start using compound measures. In this case, it's speed, distance, and time. Using compound measures, it's handy to think about them in a version of this triangle that we can see here. The distance is on the top, and speed and time are in the bottom 2 corners. Let me show you how we can use this to solve this type of question. We have a car travelling 100 miles at a speed of 40 miles per hour, and we're asked to calculate how long it will take. If I'm trying to calculate the time, that equals distance over speed, or distance divided by speed. So time will be calculated by 100 miles divided by 40 miles per hour to give 2.5 hours. As the speed was in miles per hour, we can say that it's 2 hours and 30 minutes. In this question, we have a jumbo that flies at a speed of 484 miles per hour for 4 hours and 30 minutes, and we're asked to calculate how far it travels. A quick note to say that before starting any calculation with time, make sure it starts with the unit of measurement that you want to calculate with. In this question, as the speed is miles per hour, we will need the time as hours. So 4 hours and 30 minutes will be converted to 4.5 hours. Next, if we look at our triangle, we can see that we find distance by calculating speed multiplied by time, as neither is above the other. So to calculate the distance, we will do 484 times 4.5 and find that the jumbo has travelled 2,178 miles. For this question, we're told that the speed limit on a road is 40 miles per hour, and a scooter drives 9 miles in 13 minutes. If we review our triangle, we can see that speed equals distance divided by time, so our speed will be 9 miles divided by 13 minutes. I'm choosing to use minutes in this case, as 13 minutes cannot be easily changed into a decimal of an hour. I'll convert it from miles per minute to miles per hour afterwards. So 9 divided by 13 is going to give me a decimal, which is 0.692307 recurring. I can multiply that by 60 to get 41.538461, or roughly 42 miles per hour. I can safely say that they're breaking the speed limit. In the next question, Adam goes for a walk and gets coffee. When dealing with distance time graphs, always pay special attention to the labels and the scale of the axes and what they represent. We're asked to calculate his speed for the first 1 hour and 30 minutes. Remember, we calculate the speed by distance divided by time. And if you look at the graph, we can see in the first hour and a half, he did 6 miles. So we can calculate this as 6 miles divided by 1.5 hours will give us 4 miles per hour. We're now asked how long he stopped for coffee. We can tell he stopped as the line changes to horizontal and means that he's no longer moving further away from or returning home. If we draw these lines into the time axis, we can see that he stopped between 10:30 and 12 o'clock. So we can say he stopped for 1 hour and 30 minutes. In the final part of this question, we're told he hired an electric scooter to get home, and it goes at an average speed of 12 miles an hour. We're asked to calculate what time he got home. Remember, time equals distance divided by speed. So 6 miles divided by 12 miles per hour will be 0.5 hours, or 30 minutes. As he started to go home at 12 o'clock, we can say that he got home at 12:30. In our next question, we'll be calculating density, mass, and volume. Again, we're going to use a triangle that represents our 3 measurements. In this question, we've got a piece of wood that has a mass of 7 grams and a volume of 10 centimeters cubed, and we're asked to calculate its density. Using the triangle, we can see that density is mass divided by volume. So we can calculate the density by 7 grams divided by 10 centimeters cubed, which is going to give us 0.7 grams per centimeter cubed. In this question, we're told that a rod with a volume of 50 centimeters cubed is made from copper, which has a density of 8.9 grams per centimeter cubed. And we need to calculate the mass. The triangle shows us we're going to do this by density times the volume. So we can calculate the mass as 50 centimeters cubed times 8.9 grams per centimeters cubed, which equals 445 grams. In this problem, we have a 50-gram piece of wood, which has a density of 0.4 grams per centimeter cubed. If we look at the triangle, we can see that volume equals mass over density, or mass divided by density. So we can calculate the volume by doing 50 grams divided by 0.4 grams per centimeter cubed, which equals a volume of 125 centimeters cubed. Lastly, we're going to look at the compound measure involving pressure, force, and surface area. When you're dealing with force, it's handy to remember that it's measured in newtons, which you might recognise from a science course that you've done. When we're talking about the area, we're referring to the surface area of the shape that is applying the pressure. as opposed to the whole surface area of the shape. In this first question, we have a box that's placed on a table. It exerts a force of 250 newtons on an area of 20 centimeters squared. If we look at our triangle, we can see that force is on the top with pressure and area on the bottom corners. So pressure equals force divided by area. So 250 divided by 20 will give us 12.5 newtons per centimetre squared. In this question, we're told that the area of contact is 16 centimetres squared and the pressure exerted is 10 newton meters per square centimetre. The triangle shows that force equals pressure times area, so force is going to equal 16 centimetres squared by 10 newtons per centimetre squared. And this equals 160 newtons. In the last question, we're told that an object exerts a force of 420 newtons on a floor, and the pressure on the floor is 20 newtons per square centimetre. What's the area of the contact face? If we look at how to calculate the area on the triangle, we can see that the area is calculated by force divided by pressure. So we can calculate the contact area by 420 newtons divided by 20 newtons per centimetre squared to give us 21 centimetres squared. In this video, we looked at conversion tables and how to construct them from a given ratio. We used our formulas to calculate a range of compound measures and used the triangles to remember which are multiplied and which are divided. In the next video, we'll be looking at the foundations of creating angles and the facts that we can assume from them. I'll see you then.